You must have heard about end-to-end AI models, where companies and partners are actually working on a big AI model that basically takes in sensor inputs and then on the other side gives driving instructions to the vehicle, right? So that can be one very good example, Junko, where you have this big AI models replacing some traditional codes and algorithms. Up until recently, we were even now to some extent, we talk about there's so much lines of code that needs to go into a software-defined vehicle. Now then, think about tomorrow when an AI model can replace the lines of code, which is adding to the complexity.
ARM is the industry's highest performing and most power efficient compute platform with unmatched scale that touches 100% of the connected global population. Together with the world's largest computing ecosystem and 22 million software developers, ARM is building the future of AI. Hi, my name is Junko Yoshida. I'm the host of Junko's Talk to Us, and we have been doing this domain-specific AI video podcast series with Ron Wilson, my colleague, my longtime friend, who has been helping me out to ask really tough technical questions. Hi, Ron, how are you?
Hey, Junko, how's it going?
Good, good. So today is actually episode 2 of the automotive series. Ron and I discussed actually a few years ago, how should we cover artificial intelligence? It's one thing to cover AI from the processor point of view, how much processing power needed and where does it go, inference versus learning, training. There are a lot of ways to cover it. But then actually we had the opportunity to talk to, remember, Ron, we talked to Missy Cummings at George Mason University. And Missy is the one who told us, the best way to cover AI is domain specific, because domain by domain, the needs for AI, how it is applied, is going to be different. And I think I took that advice to heart, but I couldn't figure out how to do it until decided to launch this video podcast. So without further ado, I'd like to introduce actually this guest that I wanted to have for a long time, Suraj Gajendra. Hi, Suraj.
Hey, Junko, how are you? Nice to
So
be here.
Suraj, yeah, Suraj is the Vice President and Product and Software Solutions Automotive Business at ARM. So he's been kind of my go-to person at ARM when I get confused, all the marketing jargons out there. So I'm really glad to have Suraj with us. And actually, I want to start this conversation with, when we talk about AI in automotive, the first thing everybody thinks about is robotaxi. We will get to that, but we're not going to start the conversation from there. We are going to start the conversation about what are the applications? What are the AI-driven automotive applications? I think there are a lot of low-hanging fruits, and things are already, up and running. So let's start from there. Is that okay, Suraj?
Absolutely, Junko. Absolutely. And just to add on one point to the fascinating conversations that we've basically had. Still remember that embedded world conversation was supposed to be 30 minutes, and we ended up talking for like 2 hours.
I know that was a long conversation.
I know, and then it was right. Our marketing teams and our PR teams are like knocking at the door. I'm like, come on, guys, you got to end this. You got to, this is way beyond. And they were also worried about what Suraj is going to say. So I'm just kidding. But yeah, so no, it's always wonderful talking to you, Junko, and Ron. Nice to talk to you today as well. AI, it's crazy. I mean the way it's changing the world that we live in is just unbelievable. Automotive is not left out, right? And as you rightly said, Junko, I still remember those days in 2017 through 2019 when we were talking about autonomous driving taking over the world in like 2 years or 3 years, right? People making bold claims around, hey, the cars will be driverless literally in like 2 years. But then again, obviously reality sunk in, and then we basically now have to look at all the technology, all the regulatory approvals and alignment that needs to happen, and so on and so forth. But as you put it, I think you know the good thing that could happen to the AI world is the advent of LLMs, generative AI in general, because that is unlocking a lot of applications that can be enabled sooner and quicker, right? Now, in the space of automotive, when people talk about automotive electronics, you basically have cockpit, you have all of the cockpit functionalities, you have the ADAS, of course, going all the way onto level 4, level 5 autonomy, and then you have other vehicle control systems. When I go talk to our partners about AI and applications, talking about AI-defined vehicles, what we also mean, in addition to the robo taxis and everything that's happening in the ADAS domain, is stuff that's happening in the cockpit domain, right? I mean, you have multimodal generative AI cabin co-pilot that people are actually working on. So what that basically means is you have on-device large language models that fuses voice, gesture, vision, and all of that stuff, and then builds on top of that and has very, very interesting applications. You have for whatever good or bad reasons, you have immersive gaming. Maybe one day for that completely driverless cars. Okay, you don't want to play a game when you're actually
That'll be
driving.
the days, Raj.
Exactly, right. So things like that. I mean, it's and the other use case that we're actually sort of talking about is bring your own personal assistant. Like, for example, you have your AI enabled personal assistant at home, for example, some sort of a device that you interact with, like, okay, like an Alexa device. Okay, what's the weather like today? How is the traffic going from my home to work? And taking that interaction that you have with your personal assistant at home into the car, and having that conversation, continuing with that conversation with the cockpit, and having a personal assistant in the cockpit. So it's just there are so many applications that people are actually now working on. We are living in a world these days where AI is just changing a lot of things, and then some of these low-hanging fruits that is replacing some of the traditional way how we interact with the car and how we sort of get the driving experience in the car is changing massively, right? And one classic and last example that I love is replacement of the user manual in the car. So remember that 500-page document? I did see a couple of companies working on replacing that with an AI model that you can then interact with the car, right? And say, okay, there is this light on. What do I do about it? Okay, what is the tire pressure that I need to maintain, in this weather conditions for my car, and so on and so forth. Instead of you go looking at the manual, you basically interact with the car, and the car will be able to tell you this is what it is, right? So things like that. Those are all things that are actually very quickly being developed and deployed, and will add to this experience, and then obviously moving on to the robo taxi in the future.
Right. Interesting. But some of the examples you just gave me is just a little bit beyond of what we already have in our cars today, right? Because there's a lot of computer vision, all the sensors inside the vehicles see things better, but also making decisions better, right? So where I tend to get lost is really the connection between what we have done so far,
Right.
using AI to make the vehicle safer,
Right.
versus the emergence of LLM. How
Right.
does that connect?
Yes. No, it's a great question, and I'll tell you. Before I go answer that question, let me just tell you one other. So ARM, as you guys very well know, is the technology supplier. We basically supply our compute IPs to the whole ecosystem, right? Be it the individual IPs that we've been sort of supplying to the whole ecosystem, or the compute subsystem that we launched recently, right? But we end up, working on the core technology and making sure that, the compute horsepower and the interconnects and all of the details that goes into functional safety, that goes into real-time quality of service, that goes into security aspects, all of them are baked into those processors, into those devices that gets enabled. Now, when we work with, say, our silicon partners or OEMs who are actually now building silicon, we generally, in the traditional timeline, Junko, we were like 5 years before the car eventually, goes on the road with our IP, right? So you imagine, up until now, and I'm saying traditional because China has changed the timeline significantly. I'll come to China in a second. So the IPs that we launched in 2021 or 2020 is now coming out in the car because there is a time, development time that's actually needed for the silicon and then the platform and the qualification and software and all of that stuff before the car, comes onto the road, right? So when we think about these use cases and challenges, we are like, okay, we got to think about 5 years down the lane. Okay, we got to think about what might happen, right? So, but now two things are happening. I mean, that's impossible in this today's world with all of the AI applications and LLM. I mean, come on, like 3 years ago, we didn't know where this is going to go, right? Forget about 5 years, right? So things are changing so quickly, and it's impossible for us to basically future-proof the hardware with, okay, exactly this is what is needed, right? But at the same time, fortunately, now bringing in China, the development cycle has shrunken significantly, right? It's no longer, again, I'm not saying, we're bypassing qualification and stuff like that, but we are coming in with new techniques like what software can be enabled on virtual platforms, what software can be enabled on models of hardware. How do we sort of keep that going so you don't have to eventually wait for the actual hardware to then think about software development, right? So with all of this, and then now bringing in LLM, it's, I mean, look, it's just the fundamentals of what actually needs to run an LLM versus any other algorithm that we have seen is at a core level is not when you think about CPU, GPU, and the neural processing unit, you need those aspects. Yes, the LLMs basically run more efficiently on a specific type of neural processing units or GPU, right? You need to add those acceleration capabilities into that. But then you sort of say, okay, here is my foundational. This is the IO bandwidth that I'm going to support. This is the memory bandwidth that I'm actually going to support. Here are my core elements of compute. And then you sort of say, okay, here's a perception-based algorithm that needs, this capability and this bandwidth. And then you basically have an LLM-based model of the same application, if you will. And then that will, basically make use of the hardware that you have. So what I would say is there are learnings that we already have based on all of these partners who are running LLM-based models on ARM technology, which we are feeding into our design as we go. But the idea of having software development, LLM-based application development run in parallel with the hardware development will give us that edge that is needed in order to go make sure that the hardware is, people call it hardware software co-development, co-design, or whatever, but it gives us that understanding and edge on what exactly, how much compute do we have to go put in and how do we sort of go enable. Not exactly, but to some extent, to a reasonable extent.
That actually begs the question. I understand where you guys are coming from because you are the IP provider. So you're concerned about the application that become mainstream, not this year, but a few years from now, right?
Exactly. Yeah.
As you said, China is speeding up the whole process, but still, because some of the examples you gave me about LLMs, oh, really? The LLM is going to be used for playing for computer games? Okay, user manual, I hear this all the time, but
yes.
I'm not totally sold on how LLMs would be actually useful in automotive context. In other contexts, whether consumer products or industrial, I kind of get it. But on automotive specifically, where does it shine?
Right. I think, again, so let me, you must have heard about end-to-end AI models, okay? So which is again, it's largely an ADAS application or ADAS terminology, where you have basically where companies and partners are actually working on a big AI model that basically takes in sensor inputs and then on the other side gives driving instructions to the vehicle, right? So it replaces a whole lot of software algorithms that is mostly, like traditional perception path planning based algorithms that is getting replaced by a single AI model, right? We do work with our partners. Example, Wave Technology has been one of our partners that we're learning from, right? So who, we just did a piece with them. I did talk to their, head of software to learn, what they're actually doing, how do they enable. So that can be one very good example, Junko, where you have this big AI models replacing some traditional codes and algorithms that are generally sort of, I would say, up until recently, we were even now to some extent, we talk about there's so much lines of code that needs to go into a software-defined vehicle. Now then, think about tomorrow when an AI model can replace the lines of code that we're actually talking about today, which is adding to the complexity, right? So yes, I think, look, there are certain things that the AI models cannot do in the car, okay? When it comes to like the core control functions and the core aspects of the vehicle control, absolutely has to be meticulously planned and written and driven. At the same time, there are aspects of things that are being changed fundamentally, both from the cockpit perspective and some of the examples that I gave you, be it vision / voice / gesture based models that can then sort of have much more better and effective driver monitoring or passenger monitoring. And then there is things like end-to-end AI model that's fundamentally changing how the ADAS algorithms gets written.
You were talking about examples of applications. Do you think it would be feasible to use an LLM in vehicle to, in a sense, gamify the driving experience, to draw the driver's attention to things that are coming out low probability in the ADAS model, for instance, or to offer the driver alternative courses, that kind of thing?
Yes, absolutely. There was one example that I've actually seen from a partner in China was, again, the awareness of an LLM, okay, to do driver monitoring. For example, you have the LLM in the car was actually interacting with the navigation app in the car, right? To very effectively say, okay, this is the route that we started with, but here are the changes that actually happen in the navigation. Do you want to help me change the route? Okay. So
that's a good one. Yeah.
Exactly. And then see, today, again, I'll give you another example. So when I'm driving down the freeway, so sometimes there is an alternative, faster, route that the Google Maps, will basically prompt us. Sometimes I basically hit accept. Sometimes basically I don't, because I do want to go somewhere else before I actually go to that place, and I want to follow a path even though there is a better, faster route, right? So, but then if there is a model which understands what I'm trying to do and where I'm going, right? And it basically then prompts me a voice prompt saying, okay, here is what the plan was. Okay, based on, again, I can go more creepy into some of these things, right? Where, we can say, oh, this is your calendar, based on this is where you got to go now. And then this is what you got to go after that. But then here's the change in environment. This is the traffic condition changes dynamically. Do you want to go change your plans, right? How about this, right? So things like that. And there was one very, very funny demo that I basically saw, which was, the driver basically asked, okay, where am I? What's happening here, right? I mean, this is there's a lot of traffic. Can I basically, go take a different route and so on and so forth? Then the voice prompt basically say, you got to be there at this point. Okay, you will still be able to make it if you do this, right? This is the prediction of what's happening, and then you will be able to do this. And I'm like, okay, all right, so I'll just listen to you, right? I'm not going to do anything, right? So yeah, so things like that. I think that's, Ron, those are the things that that I'm seeing, some of the examples that are being deployed, and again, I think it's fascinating to see some of these advancements.
Neat. The other thing I wanted to ask about is, in the range of applications you described, you described things that are done with a lot of very different kinds of models. And if you work backward from application to model to software stack to hardware requirements,
right,
are you going to be able to find enough commonality to end up with one hardware platform? Or are you going to end up with 5 or 6 different hardware architectures that have to be very tightly coupled.
Yeah, wow. You just asked the question, Ron, that we were just discussing today morning. And this is a question, this is the topic we talk every single day, right? How do you scale? If a particular model or a bunch of applications need so much hardware, so much requirements in compute, requirements in IOs and stuff like that, but there is a bunch of other applications that you still have to support where you will have to optimize on some of those requirements and still be able to go to market. So let me touch upon the hardware in a second, but let me talk about the software and let me talk about what we've been trying to do from an ecosystem perspective, right? So you may have heard about SOAFEE. Okay, SOAFEE is a consortium, is a special interest group that ARM helped found it's been almost 4 years now. September 2021 is when we first launched SOAFEE, but we have been, a couple of us in ARM started working on it back in 2019, actually. The fundamental aspect of SOAFEE is to try and standardize the layers of software where there is no differentiation needed, like foundational system software. Okay, the idea is when partners use different silicon from different partners. Again, if it is all ARM based, for example, then you have the boot flows for some of that can be reused, can be similar, right? There are differentiations in some of those, boot flows depending upon what is there in the hardware, but there are a large portion of how an ARM CPU comes out of reset is how an ARM CPU comes out of reset. There's no major differentiation between one chip and the other, right? How an ARM CPU debug happens is basically standard flow. How an ARM CPU power management happens, it's basically how it normally gets done across the board, similarly, right? So what we've basically started doing is, look, in order to enable differentiation that you mentioned on, okay, from one use case to another, from one platform to another, you have to go standardize some of those layers that don't have to be differentiated, right? That was the foundational element of SOAFEE, and we've been working on all of that aspect since 4 years now with our partners. We started off with 6 governing body members, and now we are close to 150. Okay, we established that low-level foundational sort of standardization idea, and then we let partners who are there to go enable applications, and we call them blueprints, the reference applications on solving different problems in the equation. Now, so what we essentially do is, okay, we establish that hardware specification and hardware architecture, which will be scalable, right? We can actually add, additional number of CPUs or IPs that are actually needed. And then we established a standardization on top of it and say, okay, here's the foundational system software standardization. Then on top of that, depending on the domain, depending on the applications that needs to be enabled, you have domain specific middleware and then the application itself, right? Because this whole thing is so complex, as you said, you can't basically try and deal with like hundreds of variables. You have to standardize the parts of the variables where you don't have to differentiate, and then you sort of say, okay, here is where I'm going to add optimizations depending on the application. The key aspect here, given most of these applications today gets developed in the cloud, okay, and then gets deployed onto the car, and guess what? This is, we've all been very sort of, I would say, spoiled by the applications that we install on our phone, right? Which is, okay, we just install an application that we like, and then we expect it to work, so it will work. We expect the same thing to happen in the car. When we actually, deploy applications from the new applications that you get prompted, you basically expect it to work. But this is a car, and there's much more liability that you got to think about. There is a lot more validation that the application has to go through. And given all this complexity that we just talked about, be it AI or non-AI application, right, you will have to ensure that whoever develops that application in the cloud gets deployed seamlessly, right? Now, the next big aspect that one has to think about after you figure out the system software and the middleware and the hardware aspect is cloud to car infrastructure. That's the essence of software-defined vehicle. You have to build a robust cloud to car infrastructure, and that's not possible by one company. That is, the whole industry need to come together. The whole ecosystem needs to come together, and ensuring that there is very robust cloud to car software infrastructure, be it OTA, be it security software, be it any other system software aspects that needs to be established. So there is a lot to be done, Ron. I believe it's, again, it's the beginning. We are working with most of our partners together to try and enable the whole story. But as you said, the AI application is the highest level that we all sort of see, all the cool thing that it can actually do. But there is so much detail within the vehicle platform and the cloud platform that we will have to basically make work for this to be possible.
Are there pieces of the overall system that have to be isolated from each other, either for security reasons or because of real-time requirements?
Absolutely, right. So there is, we call them all together as mixed criticality, right? Mixed criticality is all about you have three angles of mixed criticality, and this is what we talk day in and day out. There's the functional safety aspect. So there are applications that need very high degree of safety. There are applications that don't need that much of safety. Okay, for example, if it's I was giving this example of parking app the other day, right? I live in London, so the parking service provider basically sent a notification to my phone saying, hey, there is this app now that you can actually install on your car. Normally, the way we do it today is we park our car, we look at where what's the code, and then we enter that code in the phone, and then we pay for it, and then we basically that we move on, right? But this application basically comes in and says, okay, I know exactly where your car is parked based on the geolocation. I'm going to sign up in the parking app and then say, here is what it is, and it'll basically book parking for 2 hours or whatever. Now, that application does not have crazy amount of safety requirement. However, it's got security requirement. Why? Because you're keying in your credit card details into it, right? So it needs, again, point of sale applications, wherever there is credit card transaction, has significant amount of security requirement, right? Because you don't want your credit card information to be leaked through that point of sale device, right? And car is no different. So you're actually feeding in your credit card information. So by the way, I still haven't been able to get that app working on my car, just for this reason, by the way. The security capabilities in that car platform, Ron, doesn't meet the requirement of what my bank needs or what the point of sale credit card security requirement needs. I'm pretty sure when my car software and my car hardware was designed 4 years ago or 5 years ago, nobody thought about this parking app company is basically going to launch a app for the car, okay, and then have all of these things figured out, right? So again, the thing is, there are mixed criticality aspect, and of course, when you're driving down the freeway at 70 miles per hour, you don't want the parking app to interfere with your driving controls, right? That needs to just stay, right? So that's where the mixed criticality aspect comes in. So and then of course the real-time quality of service, right? You absolutely have to have the timeliness and time synchronization that's needed primarily to go drive some of these real-time applications that run on the car. So looking at all the three vectors of mixed criticality, there is so much that is needed in the vehicle platform. So for ARM, that again, as I mentioned earlier, we start there. That's like our hardware technology and IPs. You may have heard about confidential compute architecture that we drive, where we create realms of security. Okay, so then you have applications basically running, depending on their security levels in realms. And that realm is not just the hardware, it all the way goes up in the software as well, right? And then you have functional safety that we embed in our hardware, right? And of course, real-time quality of service. So there's all of those threes involved, and for any application developer or system developer in the automotive space, they absolutely have to understand where in this mixed criticality spectrum that they fall, and what actually they have to support.
ARM is the industry's highest performing and most power efficient compute platform with unmatched scale that touches 100% of the connected global population. Together with the world's largest computing ecosystem and 22 million software developers, ARM is building the future of AI.